Alright, let's work on another differential equation. This one goes like this. L times di dt plus r times I is equal to e. And I of 0 equals I0. First thing I want to do is multiply dt throughout. So let's do that. L di plus r I dt equals e dt. Next thing I want to do is I want to get all the dt junk on one side. So let's start with L di and let's say e dt minus r I dt. And then let's factor the dt out. So we have L di equals e minus r I times dt. Next, let's divide both sides by this mess, and we get L over e minus r times I dt, di equals dt. Okay, so now we need to look at this left side here. Let's think about it in reverse. Let's think about what we would have to take the derivative of to have something in this form here. Well, we know that if we take the derivative of some log base e of, let's say, e minus r I, we would get 1 over e minus r I times a negative r di. So that's kind of close. Except we have a negative r di instead of an L. So what if we initially multiply by the L constant and divide by a negative r? That turns this into exactly what we need. So we know now on the left hand side we have L over negative r times the derivative of ln e minus r I is equal to dt. Now all we need to do is integrate both sides, and by doing that we get negative L over r times ln e minus r I is equal to t plus c. So that's pretty good, except we got one more issue here, that I of 0 equals I0, or I naught. So to solve for c, we just substitute as we normally do. E minus r I of 0 becomes I0, and t is 0, so all we're left with on the right hand side is c. So we know now that c equals all this mess here. So all said and done, we have negative L over r ln e minus r I equals t plus c, and if c is this, it's negative L over R ln E minus R I O. And that's a pretty big monster. What we want to do is we want to try and get I by itself. Now it's pretty buried, so let's work at it step by step. First, I want to bring this guy to the left side. It's very similar. It looks like we can factor some stuff out. So let's bring it to the other side. L over R, negative L over R, ln E minus Ri, and then we're subtracting a negative on both sides, which means we're adding, but I'm going to keep it as a negative. You'll see why in a second. It just felt like the right thing to do, to keep it as a negative. And I think it was a good idea. Minus RIO equals T. Did I get all that right? I believe so. So now we see we can do some factoring here. And what I'm going to factor out is just the negative L over R. So we have negative L over R times ln E minus R I minus ln E minus R I O equals T. Now we're working with logarithms, so there's that rule about when you're subtracting logarithm, one ln of something minus ln of something else, it turns into this. You have negative L over R, and then you just have ln E minus R I over E minus R I O, and all that is equal to T. Next, step number 500, we have ln of E minus R I over E minus R I O is equal to negative R over L times T. And we're really getting somewhere now. Next, if we raise both sides, if we raise e to the both sides, let's say, on the left hand side, you get E minus Ri over E minus R I equals E to the negative R over L T. So next we want to say E minus R times I equals E minus R I O times E to the negative R over L times T. And then if we subtract E from both sides and then invert, we have R times I equals E minus R I O times E to the negative R over L times T. Finally, we divide both sides by R and we get I equals E over R minus E minus R I O over R times E to the negative R over L times T. So that is what I claim is the solution to the problem. But of course I want to check that. So first thing I want to do is take the derivative in terms of t, and we get, what do we get? Well, this on the left is just a constant, so we bring down, so this is just a constant times e to a constant times t. The rule of finding the derivative of an exponential, you bring that down, this turns to a 0, and the negative turn into a positive, so you're left with r over L times e minus r I o over r times e to the negative r over L times t. So let's think about what the differential equation said. If we can remember back, I believe it said L times di dt plus r times I equals e. So using these two equations, let's plug it in and see what we get. We get L times di dt, which is this guy, so we get L times r over L times e minus r I o over r e to the negative r L t, and then plus r times I. See if I can fit everything in. We had e over r minus r e minus r I o over r e to the negative r over L times t. So this cancels with this cancels with this cancels this cancels this. So what are we left with? We're left with e minus r I o times e to the negative r over L t plus, all that's left is e minus r I o e to the negative r over L times t. This and this cancel out, and all we're left with that. So we've verified that. There is your solution.